Welcome back to my channel. I'm Brian Kafke, and in this video we're going to talk about using PostgreSQL to do upserts, which means maintain data, i.e. add, change, and delete data. And we're going to do it all from the Python language. So let's jump in. Where are we going? We're going to talk about the problem, which is keeping data current. Whatever happens, data is changing. What is an upsert and why do you care? And finally, the tools of the trade. And then I'll get into what is really going to be most of this presentation is going to be walking through a demonstration notebook, which you can download from GitHub, and I'll put the link in the description. So the problem is database table maintenance. So imagine you have something like a customer table that you originally took a snapshot of, say, a transaction system like from sales, but that data is going to change over time, right? Customers are going to be added and changes and deleted. So picture this situation. We have the data warehouse on the left, and this would be your own data warehouse you're using for analysis. This is Postgres. You can see the little elephant, and you see the little grid there. That represents the customer table in this case. We'll just say customer table as one example. And I'm calling it the master table. That's the one that's used for actual querying. It's like a gold copy. That's what's going to be used for slicing, dicing, and doing your analysis. Now, the data could be coming from an enterprise database, which could be SQL Server, Oracle, MySQL, or Postgres, so whatever you're using. It could also come from some sort of flat files, which could be sent from vendors, could be extracts from databases, or any number of systems may create some sort of flat files. It could be CSV, JSON, XML, whatever you're using. So these are the most common sources of data that you'd probably be using in your data warehouse. If you look in this slide, you can see that we're taking data from either the database or flat files or both, and we're going to load them into a table in the Postgres database. It's going to make it easier to do our maintenance. So we're going to pull it down, and then we can use that transaction table to be applied against the master table. That just makes it a lot easier because now we can manipulate it with SQL statements, and you'll see that our SQL statements can actually be used together to do our processing. So what kinds of changes are we thinking of? Well, there are inserts, right? Customers need to be added. Maybe we're missing some customers. There's updates. So maybe the customer's there, but there's been an address change or some new information has come in about them. And finally, we may need to delete customers. Now that last one's pretty uncommon really in a data warehouse. We tend not to delete. We may take snapshots, and by just periodically refreshing things, we automatically lose older customers, or we may do a purge for customers that haven't had any activity in a while. But deletes are a little less common, but I will cover it in my presentation anyway, so you'll know how to handle those. Now, there are two ways this could be happening. You could be getting something that's sort of pre-processed, where you're getting either a file or data from an enterprise database that already tells you this customer changed, this one's an insert, etc. Or if you don't have that, almost as good is just having a snapshot of the table. So you had a copy of the customer table a month ago, and you just want to get it up to date. Now you could truncate and reload the entire table, but maybe you don't want to really do that. Maybe it's really big and you really just want to say match it and only update it if it changes. And we'll also show you how to track what's changed, so you'll know, oh, this was updated versus it was just inserted, which gives you a little more information. So I'm going to show you just how to apply those transactions. But it could be done. I'm going to use an example that sort of has a more formalized transaction table, so it's easier to follow. But you could just use it just as easily with some sort of a snapshot from the source. So let's look at the traditional solution, which means not using upsert. In the traditional SQL world, what we would use is an insert statement when we know we need to do adds. Now, when I say, how do we know we're going to do an add? We're going to look up the row coming in from the transaction and say, does it already exist on our master table? And if it doesn't, then we're going to add it. And if it does exist, we're going to use the update statement to apply changes. And if we had something which flagged this to be deleted, that would probably indicate something from the source system might put like a little D indicator somewhere saying delete this record. Then we can also use the delete statement. The upsert doesn't help us with really the delete, but it does help us with the insert and the update, because it allows us to do this in one statement. And that's not only more efficient because it's one pass over the transaction data and applying the changes, but it's also less code and I think more intuitive to read. So what is an upsert? Well, as I just stated, it's a SQL statement that supports both inserts and updates at the same time. And it's leveraging the table's unique column to determine whether to apply an insert and update. What do you mean by unique column, Brian? What is that? If you have a relational database a transactional system, they call it. Every table should have a unique identifier, right? A column which is the unique identifier for any instance. If you think of filing taxes, for instance, in the United States, the IRS knows who's filing taxes because every person who files taxes gets a tax identifier, a taxpayer identifier, which is their social security number. And by using that, they know whose taxes go where. So having unique identifiers is critical. So in the case of the customer table, we'll have a customer key, or you could also call it customer ID, which you'll see a lot on tables. Sometimes these are generated artificially by just using some sort of an incremental column. Sometimes they're sort of pseudo-intelligent, they have some meaning. Ours are just going to be a customer key that has a number that stays with that customer. So now we need to use that customer key to match it from the transaction table to the master table to figure out if they already exist or not. The Upsert statement also provides for some additional conditional logic, and we'll see how that works. So why do you care? What do I care about all this? What do I need? Well, it makes your life easier. Yes, you could use the traditional method. Now, it's almost guaranteed you will need to do data maintenance, so you're either going to do it the insert, update, delete method, or you're going to use an Upsert. Either way will work, but using the Upsert is going to make your life a little bit easier. It's going to make less code, easier maintenance. Also, if you want to be employed and you get interviews on jobs, and Python and Postgres are very, very popular, so you're likely to get questions, you're kind of going to jump ahead of the queue if you talk about using Upsert over using the traditional insert and deletes, because it shows you're a little bit more on the ball. You know a better way to do this. And if you use the reasons I'm telling you about, I think you'll find you'll actually do pretty well on that part of the interview. Finally, you got the job, but do you know what you're doing? You got to do a lot of maintenance to these Postgres tables. Now you need to know what you're doing, and you got to keep the job. So this is where you really want to know what I'm talking about. So this is another tool in your toolbox. If you get into the data engineering world, you need to have a lot of tools, different methods, different ways of doing things. Not everything works with one tool. You got to get some variety. The other thing I will point out is I have 2 other videos I did, and I'll put links below in the description as well. I advise you to watch those. One is an introduction to Postgres, and it also talks about Python, and then the other one is using Postgres with Python. By looking at those, you'll get a better feel, which will help you build up to this video if you feel like it's a little bit much. But one of the things I do want to point out is that Postgres comes with a really nice user interface that you can install and use. If you install the Postgres database yourself, you'll get it. And it's really great because you get a nice UI that lets you look at the tables, you can write SQL queries, you can check things. Now, if you think about it, you're using a Jupyter notebook or something with Python, it's not always easy to see what's happening in the database. For instance, you may get a message saying the table doesn't exist, or the column's not right. You can then just go check the database directly. So let's jump into the demo. Now we get to the fun part. Using the Postgres Upsert statement in Python. Now, I always have this warning. This code is for demo purposes only because I might drop objects, I could delete things or whatever. So always check code carefully before you run it in your environment. Ideally here, I'm assuming you're going to be using some sort of a test database at least to see how this works. Now, if you don't have SQL Alchemy installed, you will need it. SQL Alchemy is a module that allows you to connect to various types of databases from Python. It is often used with applications like web apps, mobile apps, and something called an object relational mapper. We're not going to look at that. We're actually just going to use a piece of SQL Alchemy which integrates with pandas. So to get it, if you just install Python without something like, say, Anaconda, you can just do pip install, and that will bring it in, pip install SQL Alchemy. If you're using Conda for your package management, you can just say conda install, and there's the code for you. Just uncomment these. I didn't want to accidentally run these or have you accidentally run them. Just remove the comment, the pound sign there, and you can run those. You can also just install those separately if you're familiar with how to do that. We're going to say from SQL Alchemy, import create engine. Create engine is kind of a strange function name since all it really does is returns a database connection. So not surprisingly, we're going to call the object it returns, CONN, short for connection. And here we are calling the function. Now let me review the format of the parameter you pass because it is not intuitive. The first part of this, Postgres or PostgreSQL, is actually just telling the type of database. This is Postgres, right? The next part, plus, this part is the driver. So scicop G2 is, as far as I know, probably the most popular Postgres driver for Python, but Python has a long history of integration with Postgres, so there's actually a number of drivers you can choose from. That's what I'm using, so that's what I'm testing with. The next part is the username. I'm just going to make this as easy as possible for you, so I'll just use the Postgres default username you get when you create your instance of Postgres. So you'll get Postgres, and you can use that. I assign the password Brian, so colon then the password Brian in my case. That's whatever you assigned. And then you have the server instance. Most enterprise databases allow you to create a server instance, and under that instance you can create any number of databases. So you think of it as like a server, and then under that many databases. And the default is called localhost. So there, if you've installed Postgres and you only have one instance, that's what you want to use, the local one on your own machine or whatever, you can just use localhost. If you're using an environment with many instances, then you can just put in whatever the server name is for your environment. And I'm going to make this really easy because I'm going to use the default database on that instance. In other words, Postgres comes with sort of a default public database, if you will, called Postgres. So I'm just going to use that, so you don't have to worry about creating a whole new separate database. All right, so let me run this. I'm doing Control Enter or maybe Shift Enter in some cases. Nothing's returned, so we don't see anything. Now that I have the connection, I can execute statements by using the connection object and then different methods, in this case the execute method, and then I can pass my SQL statements in as a string. So here I'm saying drop table if exists YouTube customer. Now I'll show you too, you may need to use a doc string. It doesn't hurt to use a doc string, which is 3 quotes instead of a single quote. But what I want to do here anyway is drop table if exists YouTube customer, and I'm prefixing it this way so that in case you have a table called customer, it won't affect, you won't drop it. So here we say YouTube customer, that's going to be our master table, and then we're going to drop the table if it exists YouTube cust_trans. I'm just doing this so that you can rerun this if you want to try it out again. So run that, and the next thing we want to do is create our master table. So we're going to use con execute again. As I mentioned, here we're going to have to use a doc string because it's multiple lines. The name is YouTube customer, and then in the parentheses we pass the definition. The most important column probably is customer key. And I want to point out that I'm using all lowercase. Postgres is extremely sensitive to case. So if you use mixtures of upper and lowercase, then you're always going to have to put quotes around column names when you're running queries, etc. So we're using customer key. It's going to be an integer, it's a primary key, and since it's a primary key it cannot be null because we always need that identifier. We're then going to have last name, and I'm just defaulting these columns as text, so last name, birth date, marital status is text. Yearly income is a real number, and modified date is text as well. I could have made that a date, and then we'll just say elapsed timestamp default current timestamp. So let's run that code. Now we're going to have to import pandas. Oh, let me go over something else here. What's going on with this column? I'm actually adding a little value add for you. If you're going to be doing engineering work, data engineering work, you should know a few best practices. And one of them is whenever you're updating, inserting, and maintaining tables, you need to have at least one column, sometimes two, that tells you when the data was last changed. 2 columns if you want to say this is the initial insert, and another column says last update date. It's really good practice to have that. But sometimes you can get away with, as I'm doing here, ETL last update, which is if it was just inserted and never touched after that, then it's going to reflect the insert date. But if you've done updates since then, it will always get updated with the last update date. Now on an insert, I don't actually have to pass a value because I'm going to default it to current timestamp, which is a Postgres reserve variable that will plug in there as whatever the current date time is when I do the insert. So I've run that, great. We're going to now import pandas as PD, which means we need to prefix our functions with PD. And now we're going to use the PD pandas read CSV. Now why do we want to use read CSV? Well, one of the nice things about it is it returns a data frame. So we're going to get back a pandas data frame, which is a lot easier to manipulate than other formats. So we're going to get a nice CSV back. The index col equal false means we're not going to take any of the columns coming in and make them data frame index. So let's bring this in. It's going to come into custdf, customer data frame, and then we'll display it. So I'm going to run this, then I'll run this, and we can see our small data frame. And The code and everything will be available to you. I'm going to put a link in the comments as usual. But you can see we have 4 rows. We can see one of the things to pay attention to is the modified date, because it's the same on all of these rows. And this modified date represents not our ETL last update, which is our modified date, which we want internally for our own use. This is actually coming from the source system. And it's actually pretty common to have that happen, where whatever source system is doing something, they actually have a date that tells you the last time it was modified, or at very least when they sent it to you or something. So we're going to use that. And in this case, they're all the same. It's great to see. And we're going to use that because when we do our updates, we can check it to see if we got the last greatest date. Now what we want to do is, we've got our data frame, we need to save it to a table. We can do that really easily in pandas by using the to_SQL method. This is one of the reasons why I love to use pandas whenever I'm doing anything with databases, because all I have to do is say to_SQL, and here I give it the name of the table. That's the one we just created. I use my connection object, and I say if exists equal append. Why does it have to say if exists equal append, Brian? There's actually 3 possible values. Good question, by the way. You can have replace, append, or fail. Fail is only applicable when you say this table shouldn't exist. I want this to fail if you try to create it because it already exists. The next one, though, is append or replace. If you say replace, then that means you want it to drop the table and recreate it. And the problem is with that, it will lose all of the changes, any kind of special customizations you have, like a primary key or the extra ETL last update column we created. So we don't want to do that. It will just basically use a raw, simple definition that pandas defines for you. So we're going to say if exists append, and that will just insert rows into the table. And we know it's empty. We just dropped and created it. And finally here, we're just saying we're not going to do anything with an index column. So that's great. And then we can run a query here. Now again, I want to call out that by reading read SQL query from pandas, we can run a nice query like this, and we get back a data frame. We could use the execute statement from Postgres, using that execute we saw earlier from the connection, but we won't get a data frame, and it's harder to manipulate and see in a notebook. So we just run this, and we get this really nice, suitable for framing, data frame view. And we can see, here's our data. It looks great. We were able to get the ETL last update populated for us. So it didn't even give us a problem, even though we didn't have that data on the column coming in. All right, now we're going to say we want to do something else. And I just wanted to call this out, which is a nice feature of enterprise databases, at least all the ones I'm aware of, is that they support a special schema called information schema, which is used to query the metadata. This is a really good interview question, so listen up. Metadata is data that describes data. In this case, this is all kinds of information about the objects in the database. What tables do we have? What indexes? What are the columns that make up the tables? What are the data types, etc., etc. It's extremely useful, and anybody who deals with databases a lot gets very familiar using what we generically call the database catalog. So here you have information schema. What I'm going to be doing is doing a read SQL again, but I can pass select from information schema, and I want to look for the table we just created, where the table is YouTube customer, and I'm going to sort it by the order in which the columns are defined, which is called ordinal position. So let me run this. You can see this connection tells us that's, again, the Postgres database. And here we see customer key, last name, birth date, marital status, all the good stuff, and lots of information. So this is a great way to get information about the table, including verifying if it created it correctly. We got our master table, and I just walked through that. You may already have one that exists in your real use case, but I'm creating one so that you can walk through this step by step in your own home. So here we want to create our transaction data frame. We're going to do the same thing we do with the master. We're going to create read CSV, and we're going to bring in the dim customer transaction file is available to you. And I'll just display it here so you can get a look at it. And it's nothing complicated. We've got 2 updates, right? You can see here and here. The action indicator is there to make it easier to show you what's happening. So the indicator here, U, means it should be doing an update. And when you see an A, these mean it should be doing an add, and the D means it should delete this row. Whether you actually create such a formalized kind of transaction table, or you have something that's really like just a copy of the table the way it should be, and you're just going to sort of merge in the data, doesn't really matter. but this makes it a lot easier to explain. And sometimes if you've got a lot of things going on, it's worth going through some additional prep work to create a formalized kind of transaction table like this. Because remember, you can go back to this and look at what happened. The one thing I do want to call out too is modify dates, because in the data above, let me go above here, the modified data is again always the same, 2019-01-01 for all of the rows. So I'm going to use that as kind of a way to identify whether or not it did the update. So now we have our transactions. Let's save these transactions using ToSQL, just as we did before, to the table YouTube_CustTrans. It's a really good practice to bring any transactions in. Don't try to just bring them in directly from a CSV, say, into a data frame and then apply them, because it's a lot easier to do the application if you create a table. It also gives you something you can go back and query. So what you want to do is you're going to persist your transaction table. Here's your connection. Now here we're doing something different. I am saying replace. Why are you saying replace this time, Brian? Didn't you just say we'll lose things? Actually, not in this case, because if you think about it, we haven't created the transaction table, which means I'm going to be lazy. I'll let pandas create it. Now I can get away with this because it's a small table and I don't really need any customizations to it. If you had, it's good for you to practice this, but if you actually had, say, 50 million rows coming in and you needed to apply that transaction file, then I would suggest you do what we did with the customer master file and custom define the table first, including a primary key for whatever the key is for the table, and any number of other indexes and constraints, whatever you need on the table, because that will make it perform a lot better when you try to do your upsert. So adjust this to your own needs. But in my case, I'm going to let it do a replace. And then I'll just do the read SQL query and take a look at what it looks like. So now we have all our transactions in a database table and we're good to go. We've got our master file and we have our transaction table. What are the transactions we're going to do? We're going to do adds, which means if the customer isn't found, we add them. We're going to do change, which is if the customer is found, then we need to update the data for them. And we're going to do a delete, which is when we see this D up here, we want to delete that customer. Now, as I mentioned before, we cannot handle deletes within the upsert. And because we are defaulting on the insert to let the default we assigned in the table definition to give a value for ETL last update, we have to supply all the column names. You can get away from that if you just supply all values for all columns. So let me just do a quick review of the basic format of the upsert statement, which, as I mentioned, doesn't actually use the word upsert. So it's kind of weird. So let's see here. We're going to basically, it's an insert statement. The upsert is really just an insert that handles key conflicts. That's really what it is. So the regular insert is simply this: insert into my table, whatever your table is. And you can either do hard-coded values or you can say select from my transactions. Great, whatever my transaction table is. So I'd be just inserting in from a table. However, what happens, as we can see from our transaction table, if some of the keys already exist? Well, we're going to get what's called a conflict. So here you give it sort of an option. You say, well, look, on conflict, whatever the key column is, then do an update instead. So if you find it, don't insert it, just update what's there, and then you can do an update and then you set your column name values based on whatever's coming in. Now, a strange thing about the syntax here is you might notice excluded dot. What is that? Excluded is the prefix. I don't know why they chose this, but it's the prefix which identifies the data coming in. So on the left-hand side represents the master table that we're updating, which is up here. The excluded prefix is coming from the transaction table. So when you assign it, you're going to say excluded dot column name. That's just a sample. You can't run this because these tables don't exist, but I just wanted to give you an example of the code. Now, one thing I should point out also is we can filter on the transaction table itself as we bring it in. And I want to do that because I don't want to process the delete on the upsert. The other thing is when we do the update, it sometimes on an update doesn't make sense to update all columns. For instance, a birth date should really never change. People don't get born again. And so therefore, you don't need to change birth date. And there could be other types of columns that you really don't need to be updating. So you can just bypass those. Let's take a look now at how this whole statement's going to work in real life. So here's our insert statement. And as I mentioned, you can see I'm giving it all of the column names that I'm going to be inserting, not including my own extra column name to track when the insert took place. We're going to be inserting this value right here, which is a query, which is going to retrieve all the columns that are above, all the ones I've listed, from YouTube CustTrans. And I'm going to be doing that where action indicator is in A or U. And I'm doing that because I don't want to apply it to the delete. So it's going to just skip over the delete transaction and give me the adds and the updates. So if I ran just this by itself, it will do all the inserts. But for the rows that are doing updates, it would give me an error. It says, I already have a value for that. You can't do that. So I handle the use automatically by saying on conflict, and then it will do this update. And by the way, suppose something was marked as an add, but it actually already exists, it will automatically handle that as an update anyway, which seems pretty good, right? So we're going to say do update, and then you just have to say set once, and then list all of the column names that you want to update. So we're going to update the last name with the incoming last name. That's what excluded means, remember. Marital status with the incoming marital status, yearly income, modified date, etc., all the way through. But the ETL last update, this means we're doing an update and it's already has a value, but we want to replace it with the current date timestamp because we've just updated it. So we're going to replace that now with the current timestamp. You have this extra thing we can do here also, which is where the excluded modified date is greater than the YouTube customer modified date. So in my case, I don't have anything where that's going to apply, but what that says is, suppose the data coming in may actually have data that's older than the data on my table. And that happens especially if you get a lot of different source systems feeding you. Well, what you can do is by testing this, I'm saying, well, if the data coming in, the modified date, and remember, modified date's from the source system, that's telling me how fresh is it, when was this updated. So if that modified date is greater than what I have on my table, YouTube customer modified date, then I can take it. Otherwise, I should skip over it because it's older data. Now, if you were actually doing this, you'd probably want to have a log that identifies you skipped over some of the transactions because of that type of reason. But it's not a bad idea to do that because you could be updating data with older data, which means you're actually making your data worse. I didn't really set this up as a date, so it may not work. You'd probably actually want to create these columns as timestamps to make that work correctly. But as I mentioned, we don't really have that here, so I'm not going to worry about it. And I did a print so you can see the beautiful code we've got here. And now let's run it. And let's verify it did what we think it should do. So what I'm going to do here is print out the transaction so we can kind of reference that. And I'm going to print out the customer table as well, ordered by the customer key. And let's kind of walk through this. So the first thing we should see is that this row would have been updated, right? Yang. And we'll know it's updated because the modified date will be 2020-0101. We go down here, we can see, yep, 2020-0101. And you can also look at the ETL last update date, which also was updated. So we know that happened. We have another update, Jones, right? And that one should be 2019-0201. And we can see that work. So yay for us, our update worked. What about our inserts? Those should be pretty easy. We don't really need much, rocket science here. These key values, 33, whatever, are so big, easy to see. These were not on our table. They are now, so good for us. And the one that was a delete, go up to our transaction, the delete was 11002. What did we do with Torres? Well, Torres is still there. We did not delete it. We also did not change the modified date. So we didn't touch Torres, which is what we wanted to do. Now, honestly, if you have a process where you're going to, after you apply this delete, it wouldn't really matter if you did update the deleted row, but it's a waste of resources. And if you have a lot of rows, it could be not a good practice. So we skipped over it, which is better. So we're going to apply the delete transaction. So we're going to say delete from YouTube customer where customer key is in. And the nice thing about using in is it can hold any number of values listed within the parentheses. So we're going to use a query to supply the customer keys we want to delete. So we're going to say select customer key from YouTube CustTrans where action indicator equal delete. So it's just going to go and pull that one number out, the 11, what is it now? 11002. But if it had hundreds, thousands, or whatever, it would pull all of them in and it would apply the delete. Run the query to confirm it worked. And you can see that there was a row between 1101 and 11003. and it's now gone, so it worked. Now we can close our connection, and it's really important to do that because that releases resources that are being tied up. Dispose is a weird word. You might forget it like I do, because if you were using, say, SQLite, it would just be closed, but that's how you close your connection. So wrapping up, we started by looking at the problem, which is keeping our data current. We get a snapshot at one point, we load it in, and we think we're good to go, but that data is going to become out of date. Customers change, customers move, etc., etc. So we got to keep it current. We talked about the Upsert, which doesn't actually use the word Upsert, and why we want to use it, which is it's efficient. It's less code than trying to do inserts and updates separately, but you can do those, but I like the Upsert better. I also mentioned, sort of a side note, you want to look at using pgadmin, which provides a nice graphical interface into your Postgres databases. It's really useful. In truth, you'll probably jump between the two tools rather than just trying to do everything in Python. For instance, you may want to write your SQL code and test it in Postgres using pgadmin, and then just copy it into your notebook or wherever you're doing your code. And then, of course, we walked through a riveting demo, which I hope you like. You can play with the code, do your own thing. I hope this is helpful. That's it for me. I hope you like this. Please leave comments, ask questions, and like, share. Until next time, I'm pulling for you. We're all in this together. Thank you.